Right now there is a war happening inside your brain. You are one side. A narrow band of invisible light is the other, and you are losing. Every evening, when you pick up your phone, turn on your laptop, or sit under a bright LED ceiling light, you are sending a signal to your brain that says one thing: it is noon. Your brain believes it, and it acts accordingly, even if the clock on the wall says 11 at night. To understand why blue light destroys your sleep, you first have to understand something beautiful. Deep inside your brain, in a tiny cluster of about 20,000 neurons, called the suprachiasmatic nucleus, a clock is ticking. This clock is not a metaphor. It is a physical, biological oscillator. Proteins are produced, they accumulate, they bind together, and then they break apart. This cycle takes almost exactly 24 hours. Every cell in your body has a version of this clock, but the suprachiasmatic nucleus is the master conductor. It keeps all the others in sync. This master clock does not run in isolation. It needs to be set. It needs to know when it is day and when it is night. If it drifts, even by a few minutes each day, your entire biology drifts with it. So evolution built a calibration mechanism, a direct wire from your eyes to the master clock. When light hits the back of your eyes, a signal travels along that wire and tells the suprachiasmatic nucleus exactly what time it is. This is called photoentrainment. But not all light is equal. Sunlight is of a broad spectrum of wavelengths. At one end are the long, lazy red waves. At the other end are the short, energetic blue waves. When you look at a rainbow, blue light is the band just past green, heading toward violet. It has a wavelength of around 418 nanometers. Blue light carries more energy per photon than red or yellow light, and your brain has a dedicated sensor that detects it and nothing else. That sensor is a protein called melanopsin. It lives inside a special type of cell in your retina called an intrinsically photosensitive retinal ganglion cell, or iPRGC for short. These cells are not for seeing, they are for sensing. When blue light hits melanopsin, the protein changes shape. That shape change triggers an electrical signal that travels not to your visual cortex, where images are formed, but directly to the suprachiasmatic nucleus. This is a dedicated line. A hot line from the sky to the clock. During the day, this is exactly what you want. Blue light from the sun slams into your iPRGCs. Melanopsin fires. The signal races to the master clock. The clock registers that it is daytime and sends out two critical commands. The first is a wake-up signal. It tells your brainstem to release norepinephrine, which activates your entire cortex. You feel alert. The second command is even more important. It tells the pineal gland, a tiny pinecone-shaped structure deep in the brain, to stop producing melatonin. Melatonin is the hormone of darkness. As dusk falls and blue light fades from the sky, the melanopsin signal drops. The suprachiasmatic nucleus detects the drop and sends a different command. It tells the pineal gland to start releasing melatonin into your bloodstream. Melatonin does not knock you out like a sedative. It is more subtle than that. It opens the door to sleep. It lowers your core body temperature, relaxes your muscles, and tells every organ in your body that the night shift is about to begin. It is the chemical announcement of bedtime. For most of human history, this system worked perfectly. The sun came up, blue light hit your eyes, melatonin stopped, and you woke up. The sun went down, blue light vanished, melatonin surged, and you fell asleep. There was a brief period of warm orange firelight in between, but fire produces almost no blue light. The system was calibrated over millions of years. Then, in a little over a century, we broke it. The first crack was the electric light bulb. Incandescent bulbs are warm and yellowish. They still disrupt sleep somewhat, but they are relatively low in blue wavelengths. The real assault began with fluorescent lights, and then with the invention that changed everything, the blue LED. A blue LED is a tiny semiconductor that emits light almost entirely in the blue part of the spectrum. It was invented in the 1990s and won its creators a Nobel Prize. It made modern screens possible. Every LED screen you own, from your phone to your laptop to your television, produces its light by shining blue LEDs through filters. The result is a light source that peaks powerfully in the exact wavelength that melanopsin is most sensitive to. When you sit in front of a screen at night, you are pointing a beam of blue light directly into your eyes. Your IPRGCs detect it. Melanopsin changes shape. The signal fires. Your suprachiasmatic nucleus receives the message and draws a simple conclusion. It is daytime. It tells the pineal gland to stop producing melatonin. And just like that, the chemical signal for sleep is withdrawn. Studies have measured exactly how powerful this effect is. Reading on an iPad for 2 hours before bed, compared to reading a printed book in dim light, suppressed melatonin by 50 to 60%. The onset of melatonin was delayed by more than 90 minutes. The total amount of melatonin produced over the night dropped by more than half. People who used screens before bed took longer to fall asleep, spent less time in REM sleep, the deep dreaming stage critical for memory and emotional processing, and felt significantly less alert the next morning. This is not a small effect at the margins. This is a strong, measurable biological assault on the sleep system, and it gets worse with time. The circadian clock can adapt to some degree, but chronic blue light exposure at night creates a condition called social jet lag. You go to bed later, but still have to wake up for work or school at the same time. You accumulate a sleep debt that never gets fully repaid. The consequences of this chronic sleep disruption go far beyond feeling tired. Sleep is when your brain cleans itself. During deep sleep, the space between your brain cells expands by up to 60%, allowing cerebrospinal fluid to flow through and wash away toxic waste products that accumulated during the day, including beta amyloid, the protein that builds up in Alzheimer's disease. When sleep is shortened or fragmented, this cleaning cycle is cut short. Sleep is also when memories are consolidated. During the day, your hippocampus, a seahorse-shaped structure deep in the brain, acts as a temporary buffer holding new experiences. At night, during slow-wave sleep, those memories are transferred to the cortex for long-term storage. Without enough sleep, the transfer fails. Memories fade. Learning from the previous day is lost. The immune system relies on sleep as well. During deep sleep, your body produces more cytokines, proteins that help fight infection and inflammation. People who sleep less than 6 hours a night are significantly more likely to catch a cold when exposed to the virus. Chronic short sleep is linked to higher rates of cardiovascular disease, obesity, type 2 diabetes, and depression. The World Health Organization has classified night shift work, which forces people to live against their circadian rhythm, as a probable carcinogen. All of this begins with a tiny protein in your eye that responds to a specific wavelength of light. That is how precise the system is. That is how easy it is to break. And that is how profound the consequences can be. The solution is not to throw away your phone and live in a cave, though some days that might sound appealing. The solution is to understand the mechanism and work with it. Blue light is a daytime signal. Treat it that way. Get bright blue rich light during the morning and early afternoon. Go outside. Open your curtains. This strengthens the circadian rhythm by making the day signal louder and clearer. A strong day signal makes the night signal more distinct. Then, as the evening approaches, start dimming the blue. Most devices now have a night mode or blue light filter that shifts the screen toward warmer amber tones. These filters are not perfect. They reduce blue light but do not eliminate it. They are better than nothing, and they should be turned on at least 2 hours before bed. But the single most effective intervention is simpler and older. Stop using screens entirely in the hour before you sleep. Read a paper book. Talk to someone in person. Sit in a dimly lit room. Let your brain detect the natural drop in blue light and start the melatonin surge that evolution designed. If you must use screens at night, there are additional layers of protection. Amber-tinted blue-blocking glasses, the ones with orange lenses that make you look like a welder, are the most effective. They filter out almost all blue light. Clear blue blocking lenses are less effective but more wearable in public. Dim your screen as low as you can tolerate. Hold it farther from your face because light intensity drops with the square of distance. Small changes compound. Your bedroom environment matters too. Make your sleeping space as dark as possible. Even tiny lights, the LED on a charger, the glow of a router, the crack under a door, can pass through your closed eyelids and subtly suppress melatonin. Blackout curtains are one of the best investments you can make for your sleep. Keep the room cool because the drop in core body temperature is part of the sleep signal. And try to go to bed and wake up at the same time every day, even on weekends. Consistency is the glue that holds your circadian rhythm together. Here is the most surprising part of this story. We are only about 20 years into the blue LED era. The first iPhone was released in 2007. The generation of children who have had screens in their bedrooms since birth is just now reaching adulthood. We do not yet know the full long-term consequences of chronic blue light exposure from childhood onward. The science is racing to catch up, but the early signals are concerning. Rates of adolescent sleep deprivation have risen sharply. Teenage mental health crises linked to sleep loss are climbing. The experiment is ongoing, and we are all subjects. But the knowledge is already in your hands. You now understand the chain. Blue light hits melanopsin, melanopsin fires. The master clock resets to daytime. Melatonin is suppressed, sleep is delayed or disrupted, cleaning, repair, and memory consolidation are cut short. The body and brain degrade over time. It is a cascade with a clear starting point and a clear point of intervention. You cannot change the fact that you live